Hi, so we're going to look at the power and the wiring in this particular video in the LA. And to do that, I've broken it down into 5 different circuit diagrams and 5 different video descriptors of the parts that go into it. So let me show you why I've done that. Basically because it's complicated to put it all on one diagram. So what I've done is I've started off giving you an overview of the power. We have a LiPo, and the power comes in from the LiPo, and it blah 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 blah, it triggers the relays, gets everything going so that you turn the boat on and off it goes. That's the first one. The second one is the radio and the servos. This is also how I actually wire the boat up in this particular order. So it helps me to do it like this, so I figured it would help you as well. So we put all the servos in, blah blah blah, and the radio, get that all going, and then we move to stage 3. Then we do the sensors. This obviously means getting the Arduino working, getting the there's 4 sensors in this boat. It's really quite complex, but we get them all working first, and we get it all reading and blah blah blah, and then we move on to the relays. And the relays are the parts which turn the boat, turn the pumps on and off and all that sort of stuff. So we get all of that working. That's really the point where everything is working. Now what I've also done is I've added an extra stage. So I don't know what you want to call this one, but the 2 parts that I put into the boat then are the bow thruster, one, and the second one is the compass. So I just added those as a bit of an add-on. As I said, I have too much time to think about this, so I'll make things far too complicated. People have complained about that. I don't care. Alright, let's go. Alright, these are the working parts in the power circuit. We have over here the LiPo. This isn't in the diagram at all, but this I plug this into here. These are worth $4 each, and they go off with a loud noise if the battery gets low. Really useful. Go through a fuse. I just hardwire that in. 40 amps is more than enough. I've only got 1/2 of this, but this is the magnetic door switch that I use on all my boats. I've run out of them, but the other half fits on there and it has a couple of wires coming off. This is the waterproof connector, which I use to connect to this, because everything has to come out of the boat, but this is bolted in. This here is the voltage reducer, which takes the 11.4 volts and reduces it down to 4.8. These are really cheap. I'd always suggest if you're going to buy one, buy half a dozen. This is the relay. I need 2 of these relays. This isn't the right one. This is a 12 volt one. And what I'm actually using is a 5 volt one. You just have to find those on eBay. And I can run that off the power output from this. Here, of course, is the Arduino Nano, and here, of course, is the RX. Okay, that's power circuit number 1. Alright, so these are the electronics. This is the power input for the LA. I'm using 2 LiPo batteries. Put them through, that's just to get more power. Put them through a 35 amp fuse, and the first thing I draw off is this voltage reducer. That's a Hobby King one. I think they're about $4 or $4.50 or something each. And the first thing that I do with that is I take it through an external waterproof connector to the magnetic switch that's on the hull. You've seen that in the pictures. This then runs back into the boat and throws the relays, the 6 volt relays, which power this boat. Now the 6 volts is what it takes to throw the relays. And interestingly enough, one of the first things that I do is that I use that to power up the 5.8 volts in the boat. The reason I've done that way is that I don't want all of the power running through this magnetic switch. I want that magnetic switch to turn those on and off, but that's all. The remainder of the power will run through here, and it will power up my receiver, and that's it in this particular model. The other thing that's going to happen is that the 4.8 volts, which goes through this relay here, will power up the Arduino through the VIN. That takes over 7.8, I think it's 7.1 volts or something, but 11.4 is terrific. Okay, this is diagram number 2. It's the radio and the servos. We've got these already. What I'm going to show you here is the main servo that I use. It's a low profile. It's Bluebird high torque BMX 705 mg. What I like about them is that they're really good for waterproofing, and they're low profile, and they've got plenty of torque, and they're cheap. That's pretty good. Okay, this is the little pressure gauge that I use. You see it sealed away in its little world, and it's an MPXV 7007G pressure gauge. You have to get the right one because it works from very, very shallow waters down to about 2 or 3 meters. This is the servo that I use for resetting the Arduino, and I simply glue that onto the side of that, as you see in the videos. This is the distance sensor, VLX180X. It's a Adafruit sensor. And this is the compass, which is a it's GY89. What I don't have here is the TCA 9548A array, which you can see now in the boat. I've only got one of them. Now these are the servos. This is the servo that sits in the sail. This is the one that sits in the rudder, and this is the stern hydroplane. And this is the servo which flicks a switch, a micro switch, to reset the Arduino. So what we have here is, obviously over here is the receiver, and out of the receiver we have the rudder coming into D2 and all of these different components as you see in the code. What I've also done though is to take a wire from R8, which is the reset, and run that straight to this servo, so it's completely separate to everything else that's happening on the Arduino. When you flick that, it earths the ground and the reset, and the thing resets. It's very, very useful. So we have here the power to all of the servos. I'm not sure that anything else is necessary to be discussed here. I think it's all fairly clear. These are for the last 2 diagrams. I've coupled it all together. We've got over here the brushless motor and the ESC that runs that. You'll find the details for that. I've got here a MOSFET. It's a P169F06. Fairly standard. They're about $2 each. These are the relay sets, but they're both wrong. This should be a 4 and this should be a single, but I don't have any more of them around. You just Google, you just get those off eBay, and that's all there is to it. The only thing that I don't have here is the self-leveling device, which you can see in the boat now. Okay, so now we have the sensors. This remains the same over here. But the sensors, we actually have 4 of them. The first 2 are the 2 distance sensors, which are in the pistons. The power is the same for all of them. I've got them here configured straight up against the 4.8 volts. which is the best way to do it. I don't run them off the 5 here on the Arduino. Obviously the ground is the ground, but these are the critical ones, the SDA and the SCL, and they run into these spots on the, it's this one and this one, on the TCA 9548A array. The other one that I've got here is the compass, and that runs into D3. So I've mixed all of that up, doesn't matter, these are actually right. The other pressure gauge, this is an analog one, so this one runs quite separately, and the signal on this goes into A3. So this A3 takes in the pressure gauge, A4 and A5 take in all of the other sensors. That's all pretty straightforward. And now we have the relays, and these are the relays that fire up the stern piston and the bow piston. And for these, you'll see the D8, 9, 10 and 11 are the trigger pins which fire up these individual relays on the relay block. Now I haven't shown everything here because to fire up the relay block you also need an 11.4 battery to assist with firing up the piston, firing up all of the different relays. What you do have here though is the 11.4 volts running through these to the motors. That's what we're running, and the 5.8 volts are just they're still just going to the receiver. I don't think there's any particular reason for having those there. Okay. And now here's the 11.5, and now we have the bow thruster and the self-leveling device switch. And where these come from is that from D12, this is where the power comes from, or 5 volts, which goes straight to this MOSFET, and the MOSFET will just connect up the on-off, connect up the switch on the self-leveling device and turn it on and off. It's very, very straightforward. But this one, AO, turns on this single relay, and the relay turns on the power to the ESC for the bow thruster, and that fires it up. That's all there is to it. We might need some other electronic whiz-bangs in there. I'm not really sure. I've got a bit of trouble with that, but if you use it carefully, it works quite well. Now the other thing that you'll notice off here is that I've got the out from the rudder, runs through here and runs to the ESC, but that's permanently connected, but it's only going to work when the power comes up. Works pretty well. Alright, that's the lot.